Am I audible? Please reply someone, please. Either you can raise your hand so I can understand. I'm audible to everyone. Just raise your hand, anyone. Okay, thank you, Aryan. Okay, so only wait for a few minutes. Okay. So just give me 2 minutes so I can share you the slide and we can start our session. Just wait for 2-3 minutes so other can. Okay, is my screen visible to everyone? I hope. Okay. Okay. So let's start with the session. Good evening to all of you. Today we are going to start with our unit number 4, that is the data center design overview. Okay. Okay. One more time, please give me a thumbs up if I'm audible. Thank you very much. And my screen is visible. Okay, thank you. One more time. So this is what your unit number 4, data center design overview. So let's start with the syllabus. Okay, before starting the syllabus again, I'm going to show you this uh, the basic thing. These are the you can say the symbols or icons for network simulator, which we basically use while we are going to design the network. Okay, so so this is what the syllabus of this unit number 4, where we are going to see the different types of data centers. Okay, like the server farms and data centers. Wait, okay. Along with that, we are going to see some LAN WAN connectivity, fully redundant layer 2 and layer 3 devices and designs for the data centers. Then we are going to see somehow the data center monitoring and the security. So this is one of the most important factor over here. Okay, so okay, so this is what the introduction part. So where we are going to focus on three main properties of data centers here. That is what is scalability, flexibility, and high availability. So we know that here we already discussed multiple time discussed regarding what is scalability, flexibility, and high availability. But still, this is a part of this unit. Since in the part of the introduction of this unit, the books also added this point, so that is why I'm going to cover here this thing. Okay, so let's understand the three most important properties of data center architecture. That is what the scalability, flexibility, and high availability. So let's start with the scalability. So what we can say about the scalability? So scalability means the data center should support the increase whenever it is a user data or application. The infrastructure should be expand easily without affecting the performance. Okay. So the key idea is what? Grow without breaking the system. Okay. What is the key idea over here? Grow without the breaking the systems. We can take the real life examples like the Flipkart Big Billion Days sales. So, but obviously traffic increased massively during that days. We can take the other examples like the World Cup T2020 match. So final match. So that time also the traffic increased very massively, very drastically changes. So uh, there are data centers that automatically scales the resources, like resources. When we talked about the resources, so we can say that the server, storage, bandwidth. So uh, because of that one, so you experience very smooth performance over there. Only because of that one. Similarly, what we can say the flexibility regarding the flexibility. So flexibility means the data center should support the new services and technologies that without redesigning the entire systems. Of data center uses the modular designs, allowing easy upgrades and integrations. Okay, so here we can say the key idea regarding the flexibility. We can say the adapt to the change easily. Okay, adapt to the change easily. So we can take the real-time examples in terms of flexibility, like a company initially runs only a single website. So later they add the mobile app, or nowadays we are adding the AI-based recommendation systems. So flexible data center allows adding these services without rebuilding the infrastructures. So this is what we can say the flexibility over here. And third point is what high availability. So when we talked about the high availability, so what is mean of high availability? We can say that data center should have no single point of failure and must provide the continuous uptime. This is what a high meaning of high availability. So these things we can achieve through the redundant servers, backup power, multiple network paths. Okay. So system should always be in a running mode. Okay. So we can say the real life example for this one high in terms of high availability, that is banking system. In banking system also you can say the ATM, UPI, net banking. So these are different services and systems that were available 24 by 7 and every time. So even if one server fails, the another take over the instance. So user never notice the downtime in this. And when we talked about the hardware failure concept, so this is what the last point of this slide where we discuss about the hardware failures. This is a concept when a component completely fails and must be replaced to the restore normal operations, that we can say the hardware failure. So that basically sometimes it includes the server hardware crashes, switch failure, disk failure. So um, there are a lot of examples for that one also. Okay. Mm, why it is okay. So this is all about the scalability, flexibility, high availability, and the last one is what hardware failure concept. So that we are going to see in details. No issue about it. So these three properties like scalability, flexibility, and high availability that ensures that the data center is efficient, adaptable, and reliable in a real world scenarios. Okay, so let's discuss the scalability in detail. So again, scalability refers to the ability of data center to grow without affecting the performance or services. That is mean of scalability. So as the number of users, or you can say the applications and data centers increase, or not data center, data increase, the data center must handle this growth efficiently. So what we can say, the first scalability supports the growth in a performance. Okay, what we can say first initially, the scalability supports the growth in a performance, like the number of devices, and then we can say the services. So this ensures that even if the demand increases, the system continuously to work smoothly. Second, what we say that here that scalability, what we can say, a scalable data center can handle the sudden traffic spike. Okay, sudden traffic spike. For example, during the peak usage time, the system should manage increased load without the packet loss or any kind of delay. Okay, so that enables the so another important aspect is the like the future capacity planning. Okay, so data centers are designed not only to for the current needs but also it supports the future expansions. Uh, okay, so when we talked about the scalability, it also allow easy addition of devices like servers, routers, switches, without redesigning the entire infrastructure. So that is also comes under the scalability. And in addition, what we say that the modern data center supports the advanced service and devices such as the load balancers, firewall, intrusion detection systems, and SSL offloader. So this can be added as it needed in a scalable architecture. So what we finally say that the scalability depends on port density and slot density. Okay, so highly density allows more devices and modules to be added. so that increase the system growth and potential. We can take the real-time examples of Amazon e-commerce website, Flipkart sale. So during the big billion sales, as I already discussed, that millions of users access the platform. So in that scenario, data centers automatically scale up the servers to handle this type of traffic. Another real-time example, you can say the either Netflix or YouTube. So during the peak hours, mostly evening time, we can say that every platform having the very peak, heavy peak hours. So as the streaming demand increases, data center scales the resources to avoid the buffering. Third real-time example you can discuss like Google Cloud or AWS, which provide the auto scaling features, which automatically adds or removes server uh, based on whatever demands that consumer keeps. Okay, and last real-time example you can discuss like banking system. So during the salary days, okay, this is a very favorite part of the every employee. So during the salary days or festivals, when we talk about the salary days, means what the first, second, third of every month, okay, or festivals, or you can say the transactional loads, but you can say increases during this period. So scalable system must ensure smooth transaction without failure. So what we can say about the scalability, that ensures that a data center can grow efficiently, handles high demands, and remain reliable for the future needs. Okay, so I hope you understand the meaning of scalability in data center. So we discuss a lot of things over here, like device scalability, service scalability, how without losing the packets, all these things. We discuss a lot about the scalability over here. Okay, now what is flexibility? So let's understand the second important property of data center design, which is the flexibility. So flexibility means that a data center should be able to support new devices or technologies without completely redesigning the entire system. Okay, let me clear this. What is the meaning of flexibility one more time? So flexibility means that what we say, the data center should be able to support new services or new technologies without completely redesigning the entire system. So in previous unit, we discuss enterprise application interfacing. Okay, so you can say that that is possible only because of the flexibility, the component or properties available in the data centers. So in real world scenario, that technology we know that keeps changing, new applications, new services, and requirements are introduced regularly. So instead of rebuilding the entire data center, we design it in a such a way that so it can adapt easily to this kind of changes, this whatever changes we are nowadays facing. So this is achieved using the modular designing approach. Okay, this thing is achieved because the modular design approach. Okay, in modular design, what we can say, the data center is divided into the smaller part called the modules. Each module has a specific function, so we can easily add, remove, or upgrade modules without disturbing all the whole system. So, for example, what we can say that if the more storage is needed, we can simply add a storage module instead of redesigning the entire architecture. Another important point is that the changes should not be cause the major disturbance. So all updates or additions are done using the normal maintenance window, ensuring the smooth operations. So flexibility generally ensures that the data center is a future ready, adaptable, and easy to manage. See, keep this word in mind. Okay, what I'm saying, the flexibility always ensures that the data center is future ready, adaptable, and easy to manage. So let's take some uh, real-time examples like cloud service like AWS, Azure, Google Clouds. So new services like AI. So in the first or second third second lecture, we discuss about the now AWS introduced a new service that is AI, artificial intelligence, machine learning, or any analytics that are added regularly. So we generally in that case no redesigns of the entire infrastructure we require. Another example we can say the university IT systems. So initially only websites, then later we add online examination, then we add the learning platform that is LMS. So system expands without the rebuilding the complete designs. Okay. Again, we can take the real-time example like e-commerce platform that start with the basic shopping system. Later, they add the recommendation engine and then chat supports. So, flexible architecture supports new feature really easily. So, what we can say regarding the flexibility generally ensures that a data center can quick adapt to the new technologies and business and needs without any major disruption in between the systems. So let's discuss the another important property or understand the third important property, which is high availability. So when we talked about the high availability, that means the data center is designed in such a way that the service remains continuously available even the failure occur. So this is achieved using the fully redundant architecture. So that means every critical component like the server, switches, and links, whatever has the has a backup. So if one component fails, another takes over immediately. I hope you understanding what I'm saying. So and the another important concept is here is that the failure are predictable and planned. So for every possible failure, there is a predefined failure system. Okay, what I'm saying, for there is a always for every predefined failure, we have a backup. Always we have the backup. So these are the fallback times. So there are some fallback times also. Like in that case, we are going to restore the original system. So even in a worst case scenario, the system should recover within the acceptable time. Okay, I hope you are understanding. So in every worst scenario, whatever worst scenario we have, the system should recover within a acceptable times. What is mean of acceptable times? So even though user never feels like that the system is down for 1 hour and 2 hours. Okay, acceptable time means within a some second or minutes. So now the important point to understand is that it is not just about how fast the system recovers technically. It is about how the user experience the recovery. Okay. So if the user does not notice any interruptions, then system is a truly highly we can say the highly available. So high availability generally focus on and ensuring the seamless user experience. Okay. So best real-time example you can discuss regarding the high availability is like let me check the time. Okay, it's 7:60. So what I'm saying, okay, real-time examples. So online banking system. So if one server fails, backup servers handles transaction instantly. Today in the morning session we discussed regarding these things. If the one server or one node is failed, the another server take the charge of that server. Okay, so user can still transfer money without the interruptions in that scenario. Yeah, like another example, you can say the Google and or Gmail. So if the data center fails, service continue from the another locations where the user don't notice any kind of downtime. Um, Netflix again same thing. You can see the airline booking system was similarly for that one. So what we can say about the high availability. So high availability always ensures that even in a case of failure, even in a case of failure, the system continues to function smoothly without affecting user experience. Okay. When we talked about the high availability, there comes the one of the most important concept, that is the recovery time in a data center. Okay, recovery time in a data center. So, okay. So here recovery time must be measurable. So that measurable at network level, application level. So where we generally ensures about the predictability of service recovery and all these things. So now let's understand the important concept, that is the data center design. We are going to in a data center designing, which is the recovery time. So when a failure occurs in a data center, recovery can be measured in a two ways. So first we say the network recovery time means how fast the network device recover, and the second thing, application recovery time. Okay, second thing is what? Application recovery time. Means what? How fast the service become available to the user. So even if the network recovery quick, if even if the network recovers quickly, it does not guarantee that the application is available to users. So keep this in mind. Even what I'm saying, even network recovers quickly, it does not guarantee that the application available to the user. So for example, like the network might restores connectivity in a few seconds, but if the application is still loading or restarting, in that scenario, the user will still experience the delay. So that's why in a data center design, okay, that is why in a data center design, we focus more on a application level recovery, because that is directly affect the user experience. Okay, so the goal is to ensure the recovery time is ensure the recovery time is the ensure time sorry recovery time must be predictable, uh, fast enough, and within acceptable limits. This is one of the most important things. So good data center design that always ensure that the both network and application recovery are optimized, but the priority is always given to the user experience. Okay, so here the real-time example, again the banking system, Google search engine, Amazon websites. Okay, mm, or you can see the video streaming like YouTube, Netflix. So in data center design, we can say the success is not just about the network recovery, but it's about how quickly the user can access the application again. That is what we can see the success of the successful recovery of that particular application and networks. Okay, this is figure. I think somehow we already discussed some part of this figure in the unit number second. Uh, so let's understand this diagram, which shows the overall architecture of a data center and how it connects to with different networks and users. Okay, so let's see the topmost part. Okay, this top selections where we at the top we have the internet. So this is what the internet. Then we can see the service providers, service provider one and service provider two. Here you can see the PSTN, that is a public switch telephone network, and this is a partner via VPN. Okay, so this is what a VPN, and the partners via VPN, we can say that. So this represent the external world. So this part generally represent the external world connecting to data center. Okay, so service provider one, SP1 and SP2 provides the internet connectivity. So here we have that actually when we talked about here redundancy for high availability. Why we redundancy for high availability? Why I'm saying that, because here we are using two different service providers. So in case of one failure, the another will be stand for the our systems. This is what a VPN. So it is used for the secure communication with the partners, different partners we have. Okay, and PSTN supports the voice communication. So this shows the data center is not isolated; it is connected globally. Okay, this so let's discuss the next part, that is the internet age. So we have the internet edge layer over here. So this layer act as the boundary between the external network and internal data centers. Okay, this is what internal edge. Okay, this is what internal edge. Okay, you can see that. So this is what the layer act as a boundary between external. Okay, external. What I'm saying, external network and internal data centers. So here function include in a internal internet edge, we can have the function like security. So we have the firewalls and filtering systems, traffic control, access management. So it protect the internal infrastructure from the external threats. Okay, then comes the role of server farms, where server farms, okay, internet server farms. So this now look, the main part of this one is a DMZ. Already I discussed a lot about the DMZ. So it is located in DMZ. So demilitarized zone, what we can say DMZ means demilitarized zone. It is accessible from the internet, and like the host like websites and e-commerce applications. So this is a public facing part of the data center. Here we basically have the public facing part. Extranet server farm. So here we have some extranet server farm. Again, it is go through the DM there. So when we use the partners like external but trusted one, this is most important. The partner is external, but that partner must be trusted user or a trusted partner. So it access control via. So we are going to access control via the VPN again. This supports the business to business communications. Okay. So internet server farm generally used by the internal user. Okay, internet server farm generally used by the internal user, like enterprise application and databases. So this is the most secure and critical part of the data center. Why it is something I don't know. Again, we have here some core switches, that is heart of data center. At the data center, we have the core switches connect all part of the network, and does the high speed data transfer, ensure the redundancies and reliability. Okay, so this we can say is the backbone of data center. Okay, fifth we can say the internal networks. Okay, so this is what internal networks. Okay, also we have some security component like AAA, that is authentication, authorization, accounting, and RPMS, that is means of remote access management system. So this ensures the authorized user can access the resources. So what we say that the relation to the data center concept, like this diagram clearly shows how the data center is designed, and it provides the service to different user like internal, external, and partners. which again ensures the security using the DMZ, that is demilitarized zone, VPN, and AAA. It maintains the high availability using the redundant connection using the service provider 1 and service provider 2. It supports the scalability with the multiple server farms. It enables the efficient communication via the core switches. So these are the core switches. Um, we can take the real-time example of another Amazon data centers, which employs all this facility. So this diagram generally represent a complete data center ecosystem where the different user access the different services securely and efficiently through a well-designed network architecture. Okay, so so when in previous slide we discuss about we go through the internet server farm, extranet server farm, and intranet server farm. So these are the types of the servers farm. Uh, So now, along with understanding the types of server farm, it is also important to know that each server farm has its own specific requirement. Okay, so let's, for example, when we talked about the internet server farm, it requires the high security. When we talked about the internet server farm, it requires a high security and scalability. When we talked about the intranet server farm, so again high performance, and here comes the reliability, the point. And when we talked about the extranet server farm, um, okay, it basically it requires this extranet server farm requires the control and secure access. Okay, this extranet. Okay, so each type has different infrastructure. What we can say, each type, so each server farms has a different infrastructure requirement or setup, different security mechanisms, and different management strategies we generally require. So even though uh, their designs and topology may differ for the internet, intranet and extranet, although their designs and topology may differ, the basic design principle like scalability, flexibility, and high availability are common across the all server farms. So this means that while implementations may changes, the core design guidelines remain the same. Okay. In next session, we will see about each server farm in detail. So what we can say, so every server farm is a unique the same fundamental data center design principles. So keep this in mind. Okay. So let's start with the internet server farm. So let's understand the internet server farm, which is one of the most important component of data center. Internet server farm. Uh, Internet server farms are designed to face the internet, which means they are accessible to user all over the world. So user always connect to these servers using the internet, typically uh, through the web browsers like Chrome, Edge, Firefox, and so on. There are various types of browser. So these server farms support the business to consumer services. I hope you are understanding what I'm saying. So this server farm supports business to consumer service, such as the online shopping, web applications, some public websites. So anyone with an internet connection can access these services. So in addition, the external user, or you can say the internal user within the organization, can also access these services. So what we can say is that these services are really these services are rely heavily on web interfaces and web browsers, the browser based access. Okay, That is why the internet server farms are very common and uh, widely used since they are exposed to the public. They require the high security, okay, to prevent attacks and high scalability to handle the large amount of users. So internet server farms are public facing layer and public facing layer of the data center. Okay. Uh, Examples again, real time example, Amazon, Flipkart websites. So millions of users access the product online, which is hosted on internet server farms. Okay. And next one is the Google search, uh, online booking tickets, university websites. So internet server farm, what we can say, are designed to serve globally or global users efficiently through secured and scalable web-based services. Okay. Okay. So when we talk about the internet server farm, again there are two types. That is a dedicated internet server farms. Uh, okay. And the second one is the DMZ, that is demilitarized base internet server farm, that we are going to see in next slide about that DMZ based internet server farm. Now let's discuss about what is the dedicated internet server farm. Okay, okay. So this dedicated internet server farm is specially designed to support large scale internet facing applications. These applications are usually critical to the organization business. In many cases, the entire business depends on these services. For example, e-commerce platform, online service portal, web-based business applications. So this server farm supports the core business functions, meaning if they fail, the business operations are directly affected. So that is why there are um, designed with the highest. These are the designed with the highest scalability to handle the large number of users. Having the high ability to avoid the downtime, strong security to protect the to protect against the external threats. So these server farms are typically used when the company business is mainly based on the internet presence, like the websites and internet commerce, like online shopping. So dedicated internet server farm is the backbone of online business application. So again, example same, Flipkart, Netflix, Google search, and online. So dedicated internet server farm is designed to support critical online business operations with the high performance, scalability, and reliability. Okay, so this is what the dedicated internet server farm, the diagram of dedicated internet server farm. So again, here you can see that no difference over here. Okay. Okay, that's fine. We will discuss this again. Again, here comes the SP1, service provider 1, service provider 2, internet age, and this is internet server farms, a typical diagram. Okay. So, okay, I think it's almost 7:46. I have another session. So let's stop here. Okay. Okay. Tanmay want to come into the session. Okay, that's fine. Okay, now it's attendance time. So PY BDCE. Okay, from roll number 1, 2, 3. Is anyone there? Please unmute yourself. Okay, do one thing. Okay, Anushka, I got it. You're not able to unmute, huh? Okay, don't worry, Anushka. I got it. What you can do that? Yeah. And just type your roll number one by one. 1 to 5. Is anyone there? Type your roll number. Got it. Got it, Dada Sahib. Please. Okay. 2 is there. 1, 2. Okay. 2, 5. Next. Just type your roll number. 15. Okay. Very good. 6 is also there. 2, 5, 6 is there. 15 is also there. Good. Okay. 10 is also there. Good, 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 good. 37, 24, 17, 18. 17, 18. Anyone else? I hope everyone marks their attendance. No. 26. Okay, fine. Okay, anyone else? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 students are there. Only 9 students mark their attendance. Okay, that's fine. If others not ready to mark their attendance. Okay, have a nice day. Give me thumbs up. No? Okay, thank you, Nikita. Wow, Sejal. Aryan. Okay, you may leave now. Raj.